Adding and subtracting rational expressions. Adding rational expressions that have a common denominator. If a divided by b and c divided by d are rational expressions and b is non-zero, then a over b plus c over b equals a plus c over b. In words, to add two rational expressions that have a common denominator, add the numerators and keep the common denominator. In this example, find the sum x squared divided by x squared minus 2x minus 8 plus 3x minus 28 divided by x squared minus 2x minus 8. Since we have the same denominator, I can add my numerators, x squared plus 3x minus 28 all over our common denominator of x squared minus 2x minus 8. Like any fraction, we need to try to reduce it. For x squared plus 3x minus 28, I need two numbers that multiply to be a negative 28, but add to be a positive 3. So that's x plus 7 times x minus 4. In my denominator, I have x squared minus 2x minus 8. I need two numbers that multiply to be a negative 8, but add to be a negative 2. So that's going to be x minus 4 times x plus 2. The x minus 4's cancel, so my final answer is x plus 7 divided by x plus 2. I can't cancel any further because of the plus sign. It doesn't allow me to cancel out my x's. Adding rational expressions. How to add two rational expressions that have different denominators. To add two rational expressions with different denominators, 1. Factor the denominators of the expression if possible. Determine which factors are missing. 2. Use the property a divided by a equals 1, where a is non-zero, to introduce missing factors. 3. Add the expressions by using the property a over b plus c over b equals a plus c over b, where b is non-zero. 4. Simplify. In this example, find the sum 5 divided by 8x squared plus 7 divided by 6x to the third. The first thing we have to do is decide what our least common multiple is going to equal. The smallest number that 8 and 6 will divide into evenly is 24. For x squared and x to the third, you want the x with the largest exponent, which is x to the third. Then what we want to do is take the 5 over 8x squared and multiply it by our a over a. In other words, what will we need to multiply this by to get the 24x to the third? 8 times 3 is 24, and x squared times x gives me x to the third. So my a over a is really 3x over 3x. Looking towards my second fraction, which is 7 divided by 6x to the third, I need 24x to the third. 6 times 4 is 24, and x to the third times 1 is x to the third. So I need to multiply this by 4 over 4. 5 times 3x is 15x, and 8x squared times 3x is 24x to the third. Plus 7 times 4 is 28, divided by 6x to the third times 4 is 24x to the third. It's very tempting here to reduce, but we need the same denominators in order to add. So 15x plus 28 over 24x to the third. Now I need to see if I can reduce. Because I have 24 times x to the third, the only way I can reduce that with the numerator is if I have a greatest common factor. 15 and 28 have nothing in common, and only the first term has an x. So my final answer is 15x plus 28 divided by 24x to the third. In this example, find the sum 5 divided by x minus 2 plus 3 divided by x plus 4. To find the least common multiple when you have binomials, the quickest way to do this is to write down everything in your first denominator, which is x minus 2. Then looking at your second denominator, x plus 4. So our least common multiple is x minus 2 times x plus 4. Starting with our first fraction, 5 divided by x minus 2, I need to multiply this by what we're missing. We have an x minus 2, but we don't have an x plus 4. X plus 4 divided by x plus 4 is going to be my a over a. I'm going to add to that 3 divided by x plus 4. I need to multiply this by what we're missing. We have an x plus 4, but what we need is an x minus 2. So I want to multiply top and bottom by x minus 2. That's our a over a. So that means in my next step, I'm going to have 5 times x plus 4 divided by x minus 2 times x plus 4 plus 3 times x minus 2 over x minus 2 times x plus 4. Distributing, I get 5 times x, which is 5x, and 5 times 4, which is 20, over my denominator, plus, distributing my 3 times x is 3x, minus 3 times 2 is 6, and that's over my denominator. Now I can write it over one denominator, so I have 5x plus 20 plus 3x minus 6 divided by x minus 2 times x plus 4. 5x plus 3x is 8x, and 20 minus 6 is 14. And that's divided by x minus 2, x plus 4. 8 and 14 do have a greatest common factor of 2. So if I factor out a 2, that would leave me with 4x plus 7, bringing over my denominator. I cannot cancel 4x plus 7 with the x minus 2 or the x plus 4, so there is really no reason to factor. So that means that my final answer is 8x plus 14 divided by x minus 2 times x plus 4. Subtraction of rational expressions. Subtracting rational expressions that have a common denominator. If a divided by b and c divided by b are rational expressions and b is non-zero, then a divided by b minus c divided by b equals a minus c divided by b. In words, to subtract two rational expressions that have a common denominator, subtract the numerators and keep the common denominator. In this example, find the difference, x squared divided by x squared minus 25 minus 3x plus 40 divided by x squared minus 25. The key to subtraction of fractions is to remember that that minus sign goes with everything in the numerator of the fraction behind it. So when I subtract, I'm going to have x squared minus 3x plus 40. All over my denominator of x squared minus 25, which means I really have x squared minus 3x minus 40 over x squared minus 25. And now I can factor each of them and see if it reduces. For x squared minus 3x minus 40, I need two numbers that multiply to be a negative 40 and add to be a negative 3. So I have x minus 8 times x plus 5. For my denominator, x squared minus 25, x minus 5, x plus 5. My x plus 5's can cancel, so the final answer is x minus 8 divided by x minus 5. Subtracting rational expressions. To subtract two rational expressions that have different denominators, 1. Factor the denominators of the expressions if possible. Determine which factors are missing. 2. Use the property a over a equals 1, where a is non-zero, to introduce missing factors. 3. Subtract the expression by using the property a divided by b minus c divided by b equals a minus c divided by b, where b is non-zero. 4. Simplify. In this example, find the difference. 3 divided by 4a b to the third minus 1 divided by 6a squared b squared. So the first thing we need to do is find our least common multiple. Between 4 and 6, it's 12. A and a squared is a squared, and b to the third and b squared is b to the third. Looking at 3 over 4a b to the third, to get a denominator of 12a squared b to the third, I'd have to multiply my 4 by 3 to get to 12, my a by a to get to a squared, and I already have b to the third. So my a over a is 3a divided by 3a. Then I want to subtract 1 divided by 6a squared b squared. Getting my common denominator, I want 12a squared b to the third. 6 times 2 is 12, and I already have a squared, and b squared times b gives me b to the third. So 2b divided by 2b is my equivalent to a over a, which will be 1. 3 times 3a is 9a. 4ab to the third times 3a is 12a squared b to the third, minus 1 times 2b is 2b divided by 6a squared b squared times 2b is 12a squared b to the third. Now I can write it over one denominator. 9a minus 2b, and our denominator is 12a squared b to the third. We need to try to reduce it. The only way I can reduce is if 9a minus 2b had a greatest common factor. Since I don't, this is my final answer. In this example, find the difference 3 divided by x minus 2 divided by x plus 3. First thing I want to find is my least common multiple. Bringing down the denominator of my first fraction, I have x minus 2. Looking at my second fraction, I don't have an x minus 2, but I do have an x plus 3, which means my least common multiple is x minus 2 times x plus 3. So this equals 3 divided by x minus 2, and I need to multiply that by what I need for my least common denominator. I have an x minus 2, I need an x plus 3. So I multiply top and bottom by x plus 3 so that I multiply my fraction by 1. Then I want to subtract from that 2 over x plus 3. Looking at the LCM, I have an x plus 3, I need an x minus 2. So I want to multiply top and bottom by x minus 2. So now I want to distribute. 3 times x is 3x plus 3 times 3 is 9 divided by x minus 2, x plus 3, minus 2 times x is 2x, minus 2 times 2 is 4, all over x minus 2, x plus 3. Now we're ready to write it over one denominator. What we need to keep in mind is that I have 3x plus 9 minus the 2x minus 4. I'm subtracting both of them. Then write my denominator. So what that means is I'm going to have a 3x plus 9 minus 2x plus 4. The minus sign changes the sign of everything in the numerator of the second fraction. And then I make sure I write my denominator. So adding my like terms, 3x minus 2x is just x, and 9 plus 4 is a positive 13. Over my denominator, x minus 2 times x plus 3. Since x plus 13 cannot cancel with anything in my denominator, this is my final answer. In this example, we want to write the sum or difference, x over x minus 3 minus 2 over 3 minus x. One of the things we need to remember is that 3 minus x is the same as the opposite of x minus 3. So I want to rewrite my second denominator. So this equals x divided by x minus 3 minus 2 over negative x minus 3. I would have common denominators if they were both x minus 3. Since I have a minus sign and a negative, I can cancel my minus sign with my negative, making it a positive. So my result is x over x minus 3 plus 2 over x minus 3, which gives me x plus 2 over x minus 3. In this example, find the sum or difference of 4 over x squared minus 2x plus 1 over x squared minus 5x plus 6. First thing we want to do is factor the denominators. So I have 4 over x times x minus 2 plus 1 over x minus 3 times x minus 2. Then I need to find my least common multiple. The quickest way to do this, write down the first denominator. Then look at the second denominator. Do I have an x minus 3? I don't, so I need to write it down. Do I have an x minus 2? I do, so I don't write it a second time. So for this problem, the least common multiple is going to equal x times x minus 2 times x minus 3. Looking at 4 over x times x minus 2, I want to multiply that by something that's going to give me x, x minus 2, and x minus 3 in my denominator. Since I already have the x and the x minus 2, all I'm lacking is the x minus 3. So I want to multiply top and bottom by x minus 3. For my second fraction, 1 over x minus 2 times x minus 3, I need to multiply this by something that will give me x times x minus 2 times x minus 3. So the only thing I'm lacking here is x, so I want to multiply it by x over x. For this problem, I'm going to distribute and combine over one denominator. So I have 4 times x, which is 4x, and 4 times negative 3, which is negative 12, over x times x minus 2 times x minus 3. Then I have plus 1 times x, which is just x, and that's over x times x minus 2 times x minus 3. Now I can combine my like terms. 4x plus x is 5x, and then bring over the minus 12, and then rewrite my denominator. 5 and 12 do not have a greatest common factor. Since I can't reduce it, my final answer is 5x minus 12 divided by x times x minus 2 times x minus 3. In this example, we want to find the sum or difference of k plus 2 divided by k minus 1 minus k plus 1 over k minus 2. So I want to start with my least common multiple. Looking at my first denominator, I have k minus 1. Then looking at my second denominator, I have a k minus 2. So I want to write that down. So the denominator I want will have k minus 1 times k minus 2. That equals k plus 2 divided by k minus 1 times k minus 2 over k minus 2 minus k plus 1 over k minus 2 times k minus 1 over k minus 1. So using FOIL, k plus 2 times k minus 2 is k squared minus 4 over k minus 1 times k minus 2 minus, I'm going to use FOIL again, k plus 1 times k minus 1 is k squared minus 1 all over k minus 2 times k minus 1. Now I have to remember when I combine this over one denominator that the minus sign goes with everything in the second fraction. I have k squared minus 4, then I have a minus k squared, then I have minus a negative 1, which means I have plus 1 over k minus 1 times k minus 2. K squared minus k squared cancels completely. Negative 4 plus 1 is negative 3 over k minus 1 times k minus 2. In this example, find the sum or difference. X minus 3 divided by 2x squared plus 11x minus 6 minus x plus 2 divided by 2x squared plus 7x minus 4. First, we have to find our least common multiple, which means I need to factor my denominators. So I'm going to bring over my x minus 3. Looking at 2x squared plus 11x minus 6. 2 times negative 6 is negative 12. My b is 11, and my a is 2. I need two numbers that multiply to be a negative 12, but add to be 11. So that's 12 and negative 1. 12 over 2 reduces to 6. One parenthesis is 2x minus 1, and the other parenthesis is x plus 6. I'm going to subtract from that x plus 2 divided by, now it's time to factor 2x squared plus 7x minus 4. 2 times negative 4 is negative 8, my b is 7, and my a is 2. I need two numbers that multiply to be a negative 8 but add to be 7. So we're looking at negative 1 and a positive 8. 8 reduces to 4. In my parentheses, I'm going to have 2x minus 1, the other parenthesis, x plus 4. Now to find my least common multiple, I want to start with what's in my first denominator. 2x minus 1 times x plus 6. Moving to my second denominator, is there a 2x minus 1 written? Yes. Is there an x plus 4? No, so I write that down. So my least common multiple for this problem is going to be 2x minus 1 times x plus 6 times x plus 4. For my first fraction, x minus 3 divided by 2x minus 1 times x plus 6. For my least common multiple, I need x plus 4. Multiply by x plus 4 over x plus 4. Minus, for my second fraction, I have x plus 2 divided by 2x minus 1 times x plus 4. To get the LCM for this fraction, I need x plus 6. So I'm going to multiply by x plus 6 divided by x plus 6. For my numerators, I will have to use FOIL. So x minus 3 times x plus 4 will give me x squared plus x minus 12 over 2x minus 1 x plus 6 x plus 4 minus, using FOIL again, x plus 2 times x plus 6 is x squared plus 8x plus 12 over our denominator we can add like terms, but we have to deal with our minus sign. If I change that minus to a plus, it's going to change the sign of my x squared to a negative, my 8x to a negative, and my 12 to a negative, which will give me x squared minus x squared, 0, x minus 8x, negative 7x, negative 12 minus 12, negative 24, all over my least common multiple, 2x minus 1, x plus 6, x plus 4. Adding and subtracting rational expressions. To add two rational expressions with different denominators, 1. Factor the denominators of the expression if possible. Determine which factors are missing. 2. Use a property a divided by a equals 1, where a is non-zero, to introduce missing factors. 3. Add the expressions by using the property a over b plus c over b equals a plus c over b, where b is non-zero. 4. Simplify. To subtract two rational expressions that have different denominators, 1. Factor the denominators of the expression if possible. Determine which factors are missing. 2. Use the property a over a equals 1, where a is non-zero, to introduce the missing factors. 3. Subtract the expression by using the property a over b minus c over b equals a minus c over b, where b is non-zero. This also means distributing the minus sign through whatever c is. 4. Simplify.